Okay, welcome. So we're going to do an example, and in this example we're going to determine whether there are vertical asymptotes, horizontal asymptotes, or oblique asymptotes. Okay, there may be more than one in some cases. Okay, so I'm going to go through each one of these examples here and show you how to determine what asymptotes there are and what they are. Okay, and determine how to express them. So let's start with A. So in this example here, we're going to always deal with vertical asymptotes. So let's find the vertical asymptotes. Okay. So vertical asymptotes, again, we're going to set the denominator equal to 0 and solve for x. So when we solve this for x equal to 0, right? So we're going to set this equal to 0. So we're going to use the zero product principle here since it's already factored. So we're going to set this whole thing equal to 0. And so that means 2x minus 1 is equal to 0, or x plus 3 is equal to 0. And so that means that there's going to be a vertical asymptote at where? Well, there's going to be a vertical asymptote at x equal to negative 3. There's also going to be a vertical asymptote by solving this for x. We're going to have a vertical asymptote at x equals 1/2. So these are the two vertical asymptotes for this rational function. Okay. Now, if we look at the degree of the top and the degree of the bottom, so we know the degree of the top here is 1, right? It's got an exponent of 1. So the degree of the top is 1. What's the degree of the bottom? Well, in this case, if we expand this out, we've got an x here and an x here. This is going to give us an x squared. This is a quadratic, so this is going to give us a degree of 2. So since the degree of the bottom, since the degree of the top is less than the degree of the bottom, we know we have a horizontal asymptote, and it has to be at y equals 0. Why? Because whenever the degree of the top is less than the degree of the bottom, we will have a horizontal asymptote at y equals 0. And so now, at this point, we're done because there are no oblique asymptotes. But remember, oblique asymptotes only come into the picture if the degree of the top is 1 more than the degree of the bottom. Okay? So in this case, there are no oblique asymptotes. Notice also that there's only going to be either horizontal asymptotes or there may be an oblique asymptote or none. Okay? So you cannot have horizontal asymptotes and oblique asymptotes on the same graph. Okay? You just can't. So in this case here we've got vertical asymptotes, we've got two vertical asymptotes, and we've got one horizontal asymptote. All right. The next one. Okay, so let's look at this one. So now notice that, again, here, let's look at the vertical asymptotes. Okay, vertical asymptote, well, we're going to set this equal to 0. And so this equal to 0 means that x equal to 3 is going to be a vertical asymptote. Okay? And so now, what about the horizontal asymptote? Well, in this case here, notice that the degree of the top and the bottom are the same. So there is a horizontal asymptote, and the way we find it is we take the leading coefficients, and we take the ratio of just the leading coefficients, which here is just 2, and the leading coefficient here is 1. So we know we're going to have a horizontal asymptote, and it's going to be at y equals 2. And again, we're done because we know that there's no oblique asymptotes in this case. Okay? So in this case here, we have one vertical asymptote located at x equals 3, and we have one horizontal asymptote located at y equals 2. Okay. Now the last one. Okay, so now let's look at this one. Let's look at the vertical asymptotes. Okay, here again, we're going to set the denominator equal to 0 and solve. So we know that we have a vertical asymptote at x equals 2. Okay? And notice also that all of these expressions are in lowest terms. They don't have any common factors that we can factor out. If we did, if there were, we would do that first. Okay, now, what about here? Look at the degree of the top and the degree of the bottom. The degree of the top is exactly one more than the degree of the bottom. So we know we have an oblique asymptote here. So how do we find it? Well, in this case, we're going to use synthetic division. Okay, so we're going to divide. We're going to divide these two and see what the quotient turns out to be. So if we do that, we're going to do, since this is linear, right, since we're dividing by a linear term, we can use the x minus k, right? So this is our x minus c, if you will. So our value is 2. So we're going to divide, use synthetic division. And so up here, we've got 1 and 1, right? And so if we use synthetic division, we drop the 1 down. 2 times 1 is 2, right? And then add down, we get 3. Okay, so this is our remainder. And so our, hold on a second here. Did I do that right? Yeah, 2. Oh, no, I didn't. I did exactly what yeah, I'm missing a term. That's right. I knew something wasn't right. I forgot the place value, remember? So I've got to have 1 and then 0 and then 1 because I've got for the x term. So now this will work out a lot better now. So I'm going to drop the 1 down. So 2 times 1 is 2. And then I'm going to do 2. And then 2 times 2 is 4. And then this will add to 5. And then here's my remainder. Okay, now that looks a lot better. So now here's my quotient. So that means the quotient is going to be x plus 2. Okay? Okay. So guess what? This is the equation for the oblique asymptote. Okay, so we know we have a vertical asymptote at x equals 2, and we have an oblique asymptote, and it's y equals x plus 2. So it's going to be a slant, it's going to be a line that does this, okay? So that's it. So that's how you use the techniques to determine whether you have a vertical asymptote and what they are, horizontal asymptotes, what they are, or if you have an oblique asymptote, and how to find it. And that's it. Again, practice these. And again, if you have any questions, let me know. Have a great day.